So soundness is something that I've been thinking about quite a lot recently. Suppose you get a receipt from some third party that ran our ZKVM, and you run the verifier, and the verifier says, yep, the receipt checks out, everything's cool. We don't get 100% guarantee that the person who ran the ZKVM and generated this receipt was actually honest. We don't, in zero knowledge proofs, in these sorts of cryptographic arguments, we don't get a full 100% guarantee. Rather, we get up to some probability bound, up to some epsilon, which we hope is small. We can trust that the prover knows an execution trace that actually satisfies the constraints. So soundness is the analysis associated with this epsilon. Epsilon is referred to as the soundness error, and what we mean when we say we have 100 bits of security or 128 bits of security is that this epsilon is really small. The epsilon, 100 bits of security means that the soundness error is less than 1/2 to the 100th, and 128 bits of security means the soundness error is less than 1/2 to the 128th. So in this bunch of jargon, the soundness analysis is the question of how small is epsilon. And this discussion of setting parameters is what do we need to do in order to make that epsilon small?